So a couple of points that I wanted to show you before moving forward. With the query itself, and I'll paste this into the chat in case you're having a hard time seeing. The field names always have to be surrounded in double quotes. So that's how QGIS knows that you're talking about a field name and not a value. Values, however, if they're text, they need to be surrounded in quotes as well. But this time you use single quotes. So that's why, because name is the field name, that is surrounded by double quotes, and then because Boyle Heights is the value that we're testing, that is in single quotes. If you want to compare numerical values, it's best to not use quotes at all, and I'll demonstrate that in a while. But let's say then that I go ahead and that I want to go ahead and proceed with this query. I just hit OK. And there we have it. All of the other neighborhoods have disappeared, and we're left just looking at Boyle Heights. Now let's say that I wanted to, using a simple query, extract only those restaurants that are within the neighborhood of Boyle Heights, or the food facilities too. So to do this, all I would do is, it's very simple, but you're not going to be able to see this because the menus aren't visible. I would go to the vector menu, I would go to Research Tools, and then I would go to Select by Location. And Select by Location is the location-based selection and query tool. I would choose that, and then a window comes up. This Select by Location window will give you everything you need to create a spatial query. So the first box here chooses the field that we wish to select features in. And then the second is the spatial parameter. We want to select all the features from the neighborhoods, from the restaurants layer, is what we'll choose for the first one, that intersect the neighborhoods layer. If we hit OK, then you can see here we have 518 food facilities selected that intersect the neighborhood of Boyle Heights. Now let's say we wanted to get these facilities all on their own. We can create a new shapefile with this information. We can choose Save Selection As. This is very strange. It's not allowing me to make that choice. Because I'm using the wrong layer. I need to be doing that from the restaurants layer. Save Selection As. Make sure I'm choosing Esri Shapefile. And then browse, and you always want to save the shapefile somewhere convenient. We'll just create a folder called Boyle Heights. Now, I'll give it any name, BH Food Facilities. And then we can add the saved file to the map. And now we'll see that if we disable the restaurants, the main restaurants layer here, we still have the Boyle Heights Food Facilities layer. So that was a very quick demonstration of how you would perform both an attribute query to select the neighborhood of Boyle Heights, as well as a spatial query to select those restaurants that intersect the neighborhood of Boyle Heights. So now let's get into queries that are a little more complicated. Let's have a little bit of fun. So I'm going to remove this restaurants layer completely right now. And for the remainder of this demonstration, we'll play around just with these existing food facilities here in Boyle Heights. So let's say we want to construct a query. We choose filter again. And then our attributes here are the name, the address, and the city, the state, the zip, the date of the last inspection, the numerical score, the type of the facility, and the grade. So let's say we want to find only those facilities that are classified as restaurants. The type facility is the one that gives us that. So again, we can construct a very simple query here by choosing type. And then when you're comparing text values, you can use either equals or like, but it's typically best to use like. We'll choose all, and we will choose restaurant. So now you'll see that takes our numbers down considerably, particularly because this is an area where we do have a lot of industrial food storage and production. If we look at the attribute table, we'll see that we then have 262 restaurants instead of 500-something food facilities. And we can look at the names here and look at the attributes as well. So let's play around with some more complex queries as well. So let's say we want to let's build a relatively simple still compound query. A compound query is a query where you're mixing together several different expressions. So an expression is one block like this, where you have a field name, you have an operator, and then you have a value that you're using as a comparison. So let's say we want to identify all of those restaurants that have a numerical score of higher than 95 in Boyle Heights. So the expression for the second part would be score is greater than or equal to 95. In order to do this, we would choose first AND as the operator because we're combining two terms. Score is greater than or equal to 95. And again, we don't have to put quotes around that because we're using numbers. When we test this, we see that we have 111 results. If we wanted to be even more selective and choose only those that have scores above 98, we could do that too. And then if we filter this, we see that we have 36 results. And you can see that when we look through the scores here, all of the restaurants included here have a score of higher than 98 or greater, I should say. I see a question coming in. Before I move on, I'll go ahead and pause for that. What would we consider to be the restaurants with the highest numerical grades in Boyle Heights? The highest grade that I see here in the list is 100. So I would include on the chart, or I would include on the caption on your map, those restaurants that have a score of 100. All right, so that's an example of how to construct a simple compound query. Let's say now that we want to, let's get into a type of query now called wildcard queries. And this was covered in the videos, but this is where it gets kind of complex, so I wanted to do a demonstration here too. For wildcard queries, we're using an operator that says that the field name doesn't have to be exactly the same as the value that we're providing, but we want to offer a little flexibility. What I mean by that is let's say we want to identify all of those restaurants whose names begin with the letter A. We would do that. We would say name is the field, like, and then single quotes for values, the letter A, like that, right? If I test this, we see that the query returns 0 rows because this is checking to see if this is checking all of the restaurants to see if there are any fields with a name that is exactly the letter A and nothing else. If we want to include the names that have the letter A, that include other text after the letter A, other characters after the letter A, we have to use what is called the wildcard operator. And in QGIS, the wildcard operator is the percent sign. So if I include that, name, like, A, and then the percent sign, the wildcard character, we can see that when we test this, we get 23 results back. When we look at the list of attributes, we can see then that all of the restaurants that are included here, and actually because it's beyond restaurants now, it's also other food facilities. Because I removed that term, we can see that there are a bunch of different types of food facilities, but all of the names begin with the letter A. By the way, this first one here is a fantastic and very classic restaurant in Boyle Heights. If you're ever in the neighborhood, I encourage you to go there. It's very good. Let's see. The next thing we'll get into is a slightly more complex wildcard queries. So you can place the wildcard anywhere within the text. You can place also you can place an unlimited number of wildcards in the value, as long as you are as long as they are separating characters. So let's say that I wanted to look for a particular type of restaurant. let's say I was hungry for a semita, and I could place that in the name. And then if I wanted a good shot of finding a delicious semita somewhere in Boyle Heights, I could place semita in the text, the wildcard operator on either end. I could hit test, and we would then see that we have 3 rows, 3 options where we know that we could find a good semita, one of which is a catering truck, one of which is a food truck, so maybe best to go to one of these other 2 more permanent locations. So that's a quick example of how you can use wildcards in that way. Likewise, you could do the same thing with any other type of food, like a taco, for example. We could look at the attribute table. We will see that the one thing that all of these names have in common is that the one thing all of the facilities have in common is that the word taco is in the name somewhere. For some of them, it's at the beginning. For some of them, it's somewhere else in the word. Again, if we wanted to filter only those that have taco at the beginning, we would remove the wildcard here, and then we would only have 17, all of which begin with the word taco. I don't know about you guys, but I'm getting hungry. So again, you can combine these wildcards in any number of ways. So as an example, there was that bit on the assignment asking you to identify all of those restaurants that have the letters U, C, L, and A in their name in any order. Well, the way you would do that would be to start with a wildcard, because any text could come at the beginning, the letter U, and then another wildcard, C, another wildcard, L, another wildcard, A, then to wrap it up, another wildcard, and assignment close it. And in Boyle Heights, keep in mind this is not the whole city of LA, but there are 4 of them. So if we see the names here, we could see that these letters are indeed present in some way in that order, like Cuyutlán, Colima, which I guess is a restaurant. We have U, C, L, and A. Likewise here we have U, C, L, and A. So again, that's how you would complete that particular part of the assignment. Now let's say you wanted to find all of those restaurants that have the letters U, C, L, and A in their name in any order. That is going to have to be done using a compound query. You can't do that using just one query. So we would say name, like, and then U. So this would find all of those restaurants and food facilities that have the letter U in them anywhere. Now we would say and I'm just going to copy and paste here. C. Again, you need the full operator. You need the full expression. You need name like U, and name like C, and name like L, and name like A. And here in Boyle Heights, that gives us 35 food facilities. So keep in mind the most important thing here is again the fact that when you use an operator like AND, that you have a field, an operator, and a value on every side. So we have AND here, and we have a field operator value. We have AND, and then on the other side, on the right side, we have a field operator and a value before we have another AND. If I were to write the query just like this, if I were to write it like name like U and C and L and A, that would not work. That's not a valid query. You have to make sure to include the field, the operator, and the value in every expression term. So a couple more things to highlight with this assignment. I'm going to bring in the streets layer now. I'm going to turn off this filter. I'm going to bring in the streets layer, and we're going to talk just very briefly about attribute-based styling. First of all, in doing your assignment, you want to make sure that your neighborhood is highlighted on the maps that you turn in. So for your Boyle Heights, part of the assignment, zooming in like this would probably be appropriate. You also want all of the layers to be visible. So you will want probably your neighborhoods layer to be on the bottom, your streets layer to be in the middle, and your food facilities layer to be on top. What we could do here is change this so it's not such an offensive color. And now I'm going to show you how to do attribute-based styling. So we want to, in the assignments, make sure that all of the food facilities are colored on the basis of the score that they receive. That's actually very easy to do. All you have to do is choose from Properties, choose under Style, choose Categorized, choose the column, which in this case would be grade for letter grade, and we can just hit Classify. A, we would want to represent using, let's say, a darkish blue color. B, maybe a moderate to darkish green. C, we would want to be red. And non-rated, we can make that black according to the instructions. If we hit OK, we'll then see that the map is almost immediately styled that way, so that this would be the way to handle that attribute-based styling. Now there was another requirement in the assignment such that your streets shapefile should be also styled such that the major roads are highlighted. You've probably all seen maps where freeways are drawn slightly differently than arterial roads, which are drawn differently from residential roads, and so that's something that we can take care of right here. Again, we go into Categorized. The field that contains this information, as it says in the instructions, is Cardo. Then 1, 2, 3 are important. The others we can all style the same way. 1 is a freeway, so we can make this, just for now, we'll make it black. You can do it any way you want to. Make this 3 in width. You can make the middle one 2 in width. We could say 1 in width for the arterial roads, and we can leave the other as it is, thinner. I'm making all of them black, and I'm going to make this one then gray, kind of a darkish gray. So what we're doing here is we're saying freeways should be the thickest and should be black. Major roads that are not freeways, state highways, should be almost as thick and still black. Major arterial roads, think like Sunset, think Wilshire, think Santa Monica, think any one of those major roads. That would be thicker, and then all other roads will be shaded this way. Now we can see how this looks on the map. And of course, this might not be how we want everything to look when we turn it in, because the black is a little bit distracting. But there are ways to handle this. One way you can handle this, for example, is to tone down the transparency of the layer. You could make this layer 75% transparent. And there it just kind of recedes into the background a little more. It might not be the best approach to do it that way if you are using a solid color for your neighborhood. But just as an example, that's one way that you can tone down the visual intensity of your street layer. So I would think about different ways to do this. But just keep in mind that you will want the restaurants to be and the food facilities to be the real focus of attention on the map. The other thing to keep in mind here is that I selected the restaurants that fall within Boyle Heights, but I didn't filter the streets. We don't want to filter the streets because you always want to show the context of your neighborhood, what's surrounding it, how to get in and out, that kind of thing, as a point of reference. Before I close down QGIS and before we get into independent work time, Are there any questions about anything that I've covered? Okay, if there aren't any questions, that's fine. Let's see, I'll go ahead and disable screen sharing. So for the time being, then I'll go ahead and disable my audio and video. Last chance though, are there any questions about the assignment, about queries, about the midterm, about anything like that? That's a good question. This is yet to be determined. If we do have a meeting next week, there will be no assignment next week. There will be no additional assignments. The only thing that will be happening is the midterm. We may have a second